Hi guys, welcome to this physics tutorial. Today we're going to be going over the 2.4 Mechanics 2021 exam. So I'm going to do question 1 in this video and then I'll finish question 2 and 3 in another video. So let's just dive into it. Question 1, the ramp. So the picture on the right shows a bike rider going over a ramp. The rider's speed at the top of the ramp is 10 meters per second. The angle between the ramp and the ground is 30 degrees. Top of the ramp is 1.1 meters above the ground. So they'll put this in bold because it's something we need to keep in mind, so it's important. So show that the vertical velocity of the rider just as they leave the top of the ramp is 5 meters per second. So this is actually a projectile motion question in disguise. All we have to do, so anytime you're trying to find vertical, we always use sine, okay? Anytime we're trying to find horizontal, we'll call it VH, it's cos. You just got to remember that. It saves you a lot of time from trying to use trigonometry. So all we have to do is go VV equals the initial speed, so 10, times sine and the angle that they've given us, which is 30. Okay, and that should give you 5 meters per second. Okay, and that isn't achieved very easy. Okay, just 2 steps. You have to show you're working. You can't just write it equals 5 because you haven't demonstrated you know what you're doing. So yeah, next question. Calculate the maximum height that the rider will reach above the ground. So they'll put this word in bold as well, which means it is above. When we are finding our height, we also need to consider this 1.1 meters. So what we're going to do is we're going to use we have the final velocity and the initial. Now this here is actually the initial velocity. Okay? Do not use this. This is not the initial velocity, okay? It's what we just calculated. This vertical initial velocity is what we just found. That's what we use. So we're going to use this equation here. VF equals VI squared plus 2AD. We're trying to find D, so we've got to rearrange for D. So VF squared minus VI squared equals 2AD. So that means D is just equal to VF squared minus VI squared over 2A. So D will just be equal, our final velocity is 0, obviously. The initial velocity is 5. Do not use 10. 2, and our acceleration is negative 9.8 because it's going downwards. So if we do that, you should get 1.28 meters. Now, we're not done yet. We have to add on, because it's above the ground, this ramp is 1.1 meters above the ground as well. So our final answer will be 1.28 plus 1.1. Sorry about that, just cut off. So our final answer will be 2.38. Final answer with the 1.1 is a merit. Achieved is you find this 1.28 here. Okay, that's achieved. And merit. See, even forgetting this little bit here can cost you a whole grade. So let's move on to the next question. The diagram below shows the path of the rider when they leave the top of the 30-degree ramp at 10 meters per second. On the same diagram and without further calculations, which means we don't have to do any calculating, sketch the path of a rider who leaves the top of a ramp at 10 meters per second, 40 degrees. Alright, so this is different than 30 degrees. Assume the top of the ramps are in the same place, which basically means we're going to start in the same place, which is here. So, I think this is meant to, I don't know, my thing's a bit corrupted. I think it's meant to touch the ground, but whatever. So if it's all it's going at is a higher angle, so that just means it's going to go a further distance. We're still going to start in the same spot, so it's going to look something like this. It's still going to be a parabola shape. Oh, it looks a bit funky. And it's just going to end a little bit further. Just make sure your thing ends further. Alright. I'll probably redraw this because it's a bit crap. Let's make a better parabola. Oh. There we go, that's better. Okay. If you have a parabolic shape, and it's higher, and it peaks further to the right, which means it goes further, and it goes a greater distance, goes higher distance, and it starts at the same spot. If you have considered all those things, all 5, you get a merit. If you've done any 3, it's an achieved. Okay, next question. For a rider leaving the top of a 30-degree ramp at 10 meters per second, calculate the vertical speed of the rider when they land on the... Let's highlight this because it's important. Speed of the rider when they land on the ground, which basically means we're trying to find the final velocity. Okay? So we're going to use this equation, Vf squared equals Vi squared plus 2AD. We don't have to rearrange anything because it's already equal to what we want. So Vf squared equals Vi squared is 5 squared plus 2 negative 9.8, and the distance is the ramp, so what is it, 1.1? Yeah, it's the 1.1 because that's above the ground, so 1.1. Actually this should be a positive, because it's a positive because it's going in the same direction as it's falling down, so it won't be a negative anymore, so it's going to be a positive. And if you put that into your calculator, you should get 6.82 meters per second. Okay. Now we're not done yet because this is just part 1 of that question. So part 2, calculate the horizontal distance. Alright, so now we're not dealing with vertical. This is something you have to know. Okay, this is completely different from vertical. Traveled from the ramp to where the rider lands on the ground. Now remember what I said when we're trying to find... So, when we're doing these projectile motion questions, we always have to separate vertical and horizontal components. You cannot use a combination of both. That's not how it works. So, first of all, we're going to have to find the initial horizontal velocity. So we're going to have to, if we go back up here, we're going to have to use cos now. It's not the 5 anymore because that's the vertical. We're trying to find the horizontal now. So it's just going to be VH, which is horizontal, equals the 10 cos 30. Okay, the 10 is just that when it was leaving the ramp. So, yep, the 10, here's the 10, and the angle. Okay, that's where I'm getting the information from, or you could find it here. So that, if you put it into your calculator, will equal, oh, why do I stop this one? That will equal 8.66 meters per second. Alright, now that we've found the initial horizontal speed, we have to now find the time it takes, the time of the flight. So, Vf equals Vi plus At. We're going to have to rearrange vision here. We're just going to put in all the values we know. Our final velocity is the 6.8 equals the initial velocity, which we calculated at the very start was, I think it was 5. Yep, 5. So that will equal 5. Oh, plus the 9. it's going to be negative 9.8 now. Negative 9.8 t. Okay, now it's just moving stuff around so we can get what t is. So this is being added on, so it becomes a minus. So that's going to be... Actually, this 6.82 needs to be a negative. Because that's when it's going to be going downwards, right? Because the speed when it falls, it's a negative because it's going downwards. So that's where that negative comes from. So then that becomes, when we move the 5 to the other side, it will become negative 5. So negative 11.82 equals negative 9.8 t. So t is equals negative 11.82 divided by negative 9.8. T will equal 1.206 something something something, and then you just round that to t equals 1.21 seconds. Okay, now that we've found the time, all we need to do is use the basic distance equation. Now it's the horizontal distance, so we're not going to use any of those kinematic equations. We're just going to use this one here. This is the horizontal distance equation. Okay, it's not the one we used up here, because that's, or this one, because this is vertical. Okay, there's a big difference. So d is just going to equal to the horizontal velocity, so 8.66, that's why we needed to find it. It's at times 1.21. So d is equal to 10.4 meters. Okay, that's it. So this is a pretty tricky question. There's some bits you have to know, especially with that horizontal vertical stuff. You need to know the difference between the two. So if you get a final answer of 10.4 meters, that's an excellence. If you find t equals 1.21 seconds, or you get all of this, but maybe you make an error when you're trying to find the 10.4. Maybe you use like this speed here instead of the 8.6. You get merit, so merit can just somewhere over there. And then achieved is you find the 6.82. So this is achieved, or this is achieved. Any one of those two is achieved. And that's it. That's question 1 done. That was pretty straightforward. I think I went through it pretty clearly. If there's any questions, just leave a comment. Free to answer. And yeah, that's it. I'll see you soon in part 2. Cheers.